and that's for addition subtraction. Sigfig rules for addition subtraction. The answer is always going to have the same number of decimal places, not the number of sig figs. Kids every year confuse this with multiplication division. They think it's the same thing. It's pretty close, but it's not. Okay? Addition subtraction, look at the fewest decimal placeholders. I can't stress that enough for addition and subtraction. Okay? Examples. If I look here, okay, 20.44, that goes up to the hundredths place, so there's 2 decimal holders. And this goes up to 1.666, 3 decimal holders. This number is less precise than 1.666. This number dares to go 1 digit past the hundredths. Okay? So when I add these, I get this number, 22.106 milliliters. This last digit is uncertain because I don't know what comes after this 4. This is a question mark. We can't really leave it like this scientifically. So since the first number, 20.44, has only 2 decimal holders, we're going to use only 2 decimal holders in our final answer. So this number rounds to 22.11 milliliters. That's our answer. We can say that with more certainty. It might be this number, but we don't know. We're not certain. Okay. Well, what if you have problems that have mixed operations? What you're going to do is you're going to treat each operation separately based on the Sigfig rules of multiplication division and the Sigfig rules for addition subtraction. So for example, to take you through this first problem here, I look at my numerator. It's an addition problem. So I'm going to apply the addition subtraction rules of Sig Figs that I know. It's the number of placeholders. This has 2 placeholders. This has 1. So my final answer has to have 1 placeholder. Right? So if I add these up, I get 4.41, just double check myself here, 1.6. I get 6.01. 2 placeholders. I can't keep it like that because, once again, I don't know what comes after that 6. It could be a 0, it could be a 9, it could be anything in between. So I round this number to 1 placeholder after the decimal. That becomes 6.0. Okay. And the denominator here is 2.00. Now this is a division problem. This is the least number of sig figs, not placeholders. This number has a decimal, so does this number. So we're going to use the Pacific rule. It has 1, 2 sig figs, and this number has 1, 2, 3 sig figs. So my answer has to have 2 sig figs. Well, 6 divided by 2 is 3, and to have that to 2 sig figs, it's 3.0 exactly. I can't go past that 0 because I don't know what's after. In part B, once again, we have a mixed operation problem here. We have multiplication and we have an addition problem on the bottom. Okay, so I'm going to apply my number of sig figs because this is a multiplication problem. These are really small numbers here. So if I plug this numerator into my calculator, let's see what we get here. Follow me with this. So we have 0.041246 times 0.011467. And I get this number of 4.729678882 times 10 to the negative 4. There's no way I'm going to keep that. That's too long of a number. Right? So we look at our Sigfig rules. Both numbers have a decimal, so I count from left to right. I start with the 4. 1, 2, 3, 4, 5 significant figures. This number here, I start the 1, 1, 2, 3, 4, 5. They both have 5 sig figs. So 1, 2, 3, 4, 5. That's 7. Rounds that 6 up to a 7. So this becomes 4.7297. There's 5 sig figs. And don't forget your magnitude. Times 10 to the negative 4. Okay? And that's going to be divided by what we get in the bottom here. Now the bottom is an addition. We're looking at decimal placeholders. This has 2 placeholders. This has 3. So this answer has to be up to the 2 placeholders. So if I add these numbers up, 15.66 plus 100.444, we get an answer of 116.104. But I can't keep that 4 because I'm limited by what comes after the second 6. So this gets rounded to 116.10. I can put that here for certain. Okay? We're almost done, I promise. All right? This last problem is division. We're looking at the number of sig figs. Both numbers have 5 sig figs, so our answer is going to have 5 sig figs. Now what I'm going to do here, I'm going to erase this top just so we can squeeze in the final answer here. Actually, I'll put it on the whiteboard here. So 4.7297 second power EE negative 4 divided by 116.10. I get a final answer of this. 0.7381. I mean, this thing just keeps on going. It's like chemistry class, right? It never ends. 76 times 10 to the negative 6. Once again, I can't keep that. That would be crazy talk, right? Doing that. So to round this to 5 sig figs, 1, 2, 3, 4, 5. Those are 5 significant figures. The 1 keeps the 8 as an 8. So finally, after a long battle with this problem, our final answer is 4.0738, and don't forget your magnitude. Now, if you wanted to, you could also